Ladies and gentlemen, we want to now use these concepts of what we've looked at to build up a definition of what we're going to call the derivative, right? And that's the first real thing we're going to look at when we start with calculus. Now, before we do that, I want to talk about the following, okay? I want to talk about what calculus has to do with, right? Calculus, we've now seen what the average gradient is. We've looked at what is the general trend for a curve like this. What is the gradient on average across 2 points. Now, what calculus is really interested in, calculus is interested in what is the gradient at that single point. Mind blown, eh? That's what calculus wants to know. So, for example, if we look at this thing here, and we consider this to be your mood, right? You know, yeah, right? So we consider this to be your mood, because life is like that, happy on top of the moon, yay, yeah, we're like ecstatic because we got 80% in maths. And then you might move on to the next section and we're back to, you know, square one. Yeah, in touch with reality. Okay, anyway, calculus is interested in what was your mood or your day or your gradient at that specific point in time. What did life look like at that exact moment? That's what calculus is interested in. Now, given what I've already told you and given what we've looked at over the past few minutes, we've now noticed that whenever we calculate the gradient, we need two what?
2 points.
2 points. Very good. For a gradient, we need 2 points. Okay, we need 2 points. Now, that's something you know how to do. Am I right? Now, when I spoke about the fundamental principle of solving problems earlier, I said if we want to solve new problems, we need to relate it to old knowledge. So something you guys know how to do is to calculate the gradient for 2 points. But now we are introduced to calculus, and calculus tells us, I want to know the gradient at 1 point. I want to know at that exact moment in time. Now, if you think of gradient as a slope, how do you create an incline? How do you create a slope if you only have 1 point? If you're standing at a single point, where's the incline? Where's the rise for a specific run? Yes, Kayla? You had a question?
No, I have a question.
Right? Okay. So, ladies and gentlemen, as we mentioned here is you need how many points to define a gradient?
2 points.
You need 2 points. You need 2 points. You guys get it? 2 points, right? Okay. So you need 2 points. Calculus wants to know what is the gradient at 1 point. We are interested in the gradient at 1 point, a single point. Now, this introduces us to something called a problem. Right. Why, Mahir? Because you only have 1 point and you want the gradient at 1 point, but you only know how to do what?
You only know how to get the gradient when you have 2 points.
When you have 2 points. So because of that, you have a problem. You have what? A problem. Very good, very good, very good. Now because of your problem, we're going to try and help you a bit. Okay. Let's see if we can help you. Now when you relate old knowledge or new problems to old knowledge, it means we're going to try and take this 1 point and treat it as if though it's 2 points. And that's important because later on I'm going to talk about mimic polynomials and stuff where you also have to take something and try and treat it like something else, even when it's truly not that. Are you guys good? Now